Hello, and welcome to tonight's Space Sleep story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, you'll experience something remarkable. For the next 2 hours, you'll float peacefully in lunar orbit, 110 kilometers above the Moon's ancient surface. Watching Earth go through phases from 384,400 kilometers away. Understanding the gravitational dance between these two worlds. A dance that's been performing for 4.51 billion years. As you rest completely still, you'll learn how these two worlds are bound together by gravity. How tidal forces locked the Moon's rotation billions of years ago. How the Moon is slowly drifting away from Earth 3.82 centimeters per year. How ancient tides shaped both worlds across deep time. All while you simply listen, breathe, and rest. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. You are safe, comfortable, already at rest, ready to experience the eternal orbital dance. Through the window, Earth appears in gibbous phase, 3/4 illuminated by the sun. From Earth, people watch the Moon go through phases. But you're seeing the reverse. Earth going through phases from lunar orbit. The same geometry, reversed. In 7 days, Earth will be quarter phase. In 14 days, completely dark, new Earth. The dance of light and shadow playing across 384,400 kilometers of space. Your orbit is circular, 110 kilometers all the way around. But the Moon's orbit around Earth is elliptical, with eccentricity of 0.0549. That means the distance varies by 50,200 kilometers between closest approach, perigee, at 356,500 kilometers, and farthest reach, apogee, at 406,700 kilometers. Right now, the Moon is at mean distance. Not closest, not farthest. Exactly in between. Perfectly balanced in the gravitational well. The Moon beneath you moves at 1.022 kilometers per second in its own orbit around Earth. That velocity varies though. At perigee, the Moon accelerates to 1.082 kilometers per second. At apogee, it slows to 0.970 kilometers per second. This is Kepler's second law in action. Equal areas in equal times. Johannes Kepler published these insights in 1609 in Astronomia Nova, laying the foundation for understanding all orbital motion. Look at the Moon's surface passing beneath you. Same face, always pointing toward Earth. You orbit every 2 hours, seeing both the near side and the mysterious far side. But from Earth, only one hemisphere is ever visible. This is tidal locking. The Moon's rotation period equals its orbital period, 27.321661 days precisely. Not coincidence, but gravitational sculpture perfected over billions of years. Tidal locking happened approximately 4 billion years ago. Earth's tidal bulge grabbed the Moon's own tidal bulge through gravitational forces, like a friction brake applied across hundreds of millions of years. The Moon's rotation gradually slowed more, until rotation matched orbit exactly. Now the same lunar face gazes eternally at Earth, locked in gravitational embrace. Isaac Newton figured this out in 1687, publishing Philosophiae Naturalis Principia Mathematica. He explained tidal forces through universal gravitation. Newton calculated why the Moon creates stronger tides than the Sun, despite being tiny compared to the Sun's mass. The answer lies in distance cubed, not just mass alone. The Moon is 400 times closer than the Sun, and proximity matters more than mass. The ratio works out to 2.2 to 1. The Moon wins. Tidal force is proportional to mass divided by distance cubed. The Moon's smaller mass is overwhelmed by its closeness. You can feel this truth in every ocean tide on Earth. Twice daily, water rises and falls to lunar rhythm. The same rhythm you're experiencing now in orbit, the Moon's gravitational pull organizing motion across space. But tidal locking doesn't mean we see exactly 50% of the Moon's surface from Earth. We actually see 59% over time through a phenomenon called libration. Libration, from the Latin word for balance scale, the gentle rocking motion. 3 types of libration combine, each revealing slightly more of the Moon's hidden geography. This was a puzzle for centuries until orbital mechanics explained it completely. First, there's longitudinal libration, plus or minus 7.9 degrees of variation. This happens because the Moon's orbit is elliptical, not circular. When the Moon moves faster at perigee, its rotation can't keep up. We see slightly around the eastern edge. When it slows at apogee, we see around the western edge. The Moon appears to nod back and forth, revealing hidden longitudes. Second, there's latitudinal libration, plus or minus 6.7 degrees of variation. This occurs because the Moon's orbit is inclined 5.145 degrees relative to Earth's equator. Sometimes we look down at the Moon's North Pole. 6 months later, we look up at its South Pole. The Moon rocks north and south, revealing terrain that would otherwise remain hidden beyond the curved horizon. Third, there's diurnal libration, plus or minus 1 degree of variation. This comes from Earth's rotation shifting the observer's viewpoint during a single night of moon watching. At moonrise, you see slightly around one edge. At moonset, slightly around the other edge. A full Earth diameter of perspective shift. Your changing position reveals what seemed hidden just hours before. These 3 librations combine, allowing patient observers on Earth to map 59% of the lunar surface. Before spacecraft, before orbital missions, astronomers charted these visible regions. The remaining 41% stayed mysterious, hidden until Lunar 3 photographed the far side in October 1959, and remained truly unseen by human eyes until Apollo 8's crew orbited in December 1968. You're following in the path of Frank Borman, Jim Lovell, and Bill Anders. Apollo 8 entered lunar orbit on December 24, 1968 at 9:59 UTC. First humans to orbit another world. They completed 10 orbits at your exact altitude, 110 kilometers. 20 hours in lunar orbit. That Christmas Eve, they broadcast from orbit to 1 billion people listening on Earth below. Frank Borman described approaching lunar sunrise, Earth rising over the moon's horizon. The crew prepared a message for everyone back on Earth. Then they read from Genesis, the ancient words of creation. In the beginning, God created the heaven and the earth. Broadcast from lunar orbit, 384,400 kilometers from home, on Christmas Eve, one of the most watched television moments in history. Bill Anders captured that moment photographically during the 4th orbit. December 24, 1968, approximately 1640 UTC. Earth appeared above the lunar horizon. Anders grabbed his Hasselblad camera. "Oh my God, look at that picture over there. Here's the Earth coming up. Wow, is that pretty?" The photograph, designated AS8-14-2383, became known as Earthrise, changed how humanity sees itself. Another orbit begins now. You pass over the Sea of Tranquility, where Apollo 11 landed 7 months after Apollo 8's pioneering orbit. Neil Armstrong and Buzz Aldrin walked there, while Michael Collins orbited alone. July 20 and 21st, 1969. 21.5 hours of solitude for Collins. 13 complete orbits, while his crewmates explored the surface below. Michael Collins described that experience in his memoir. "I am alone now, truly alone, and absolutely isolated from any known life. I am it." If a count were taken, the score would be 3 billion plus 2 over on the other side of the moon, and 1 plus God knows what on this side. But he also said he wasn't lonely, just alone, peacefully alone in orbital rhythm. Every 2 hours, Collins passed over the landing site. Radio contact broke every time he went behind the moon, the far side blocking all transmissions from Earth. 48 minutes of absolute silence each orbit. Just the hum of spacecraft systems. The view of stars and lunar surface. Then he'd emerge, re-establish contact, check on Armstrong and Aldrin, and circle around again. From your orbital vantage, you can see how the Moon's gravitational field is irregular. Concentrations of mass, called mascons, pull at your spacecraft. These are remnants of ancient asteroid impacts, dense material buried beneath the Maria. Apollo crews had to make constant small corrections to maintain circular orbit. Buzz Aldrin, the engineer and pilot, calculated rendezvous trajectories by hand, compensating for these gravitational irregularities. Aldrin later wrote about this challenge. The Moon's gravity field is irregular. Mascons from ancient impacts pull spacecraft off course. Every orbit required corrections. The mathematics of the dance become real when you're dancing. Not just observing orbital mechanics in a textbook, actually riding the equations, feeling mass and velocity and gravitational gradient as lived experience. The Moon's orbit around Earth is inclined 5.145 degrees relative to Earth's ecliptic plane. This prevents eclipses from happening every month. Lunar eclipses and solar eclipses only occur when the Moon crosses the ecliptic during full or new moon. Twice per year, roughly. When the orbital nodes align with Earth and Sun. All other months, the Moon passes above or below the Earth's shadow. Pierre-Simon Laplace discovered something puzzling about the Moon's orbit in the late 1700s. Between 1776 and 1787, this French mathematician found that the Moon's orbital motion was gradually accelerating. Gravity alone couldn't explain it. The acceleration was real, but tiny. Tidal forces, he realized, subtly affect orbital mechanics over centuries. Patient mathematical analysis revealed what gravity equations alone couldn't show. That acceleration relates to tidal friction. The same forces that locked the Moon's rotation are now slowly pushing the Moon away from Earth. Since 1969, we've measured this precisely through lunar laser ranging. Fire a laser from Earth. Bounce it off retroreflectors left by Apollo astronauts. Measure the return time. Accurate to centimeters. And what we found? The Moon is leaving. The recession rate is 3.82 centimeters per year, plus or minus 0.07 centimeters. McDonald Observatory fired the first laser at the Apollo 11 retroreflector on August 1, 1969, just days after Armstrong and Aldrin placed it in the Sea of Tranquility. The laser pulse traveled to the Moon and back, 768,800 kilometers round trip in 2.5 seconds. Precise enough to detect the Moon's gradual drift away from Earth. This recession has been happening for billions of years. Energy transfers from Earth's rotation to the Moon's orbit. Earth's spin slows down. Moon's orbit grows wider. Currently, Earth's rotation decelerates by 2.3 milliseconds per century. Atomic clocks can measure this. Harold Jeffreys calculated this rate in 1924 and atomic clocks later confirmed his prediction exactly. When the Moon formed 4.51 billion years ago, it was much, much closer. Only 22,530 kilometers from Earth's surface. You could have crossed that distance in half a day in an Apollo spacecraft. From Earth, the Moon would have filled an enormous portion of the sky, 17 times larger in angular diameter than today. Tides were tremendous, hundreds of meters high, crashing over primordial continents every few hours. George Darwin, son of Charles Darwin, calculated this in 1879. He published On the Precession of a Viscous Spheroid and on the Remote History of the Earth. First person to work out that the Moon was once much closer through tidal evolution theory. Working backward from present tidal friction rates, calculating the ancient dance. His mathematics revealed deep time written in orbital mechanics. Earth spun faster back then too. The day lasted only 5 to 6 hours when the Moon formed. Forrest Ray Moulton calculated this in 1909, American astronomer working from tidal physics. Later, geological evidence confirmed his estimates. Ancient Earth rotated so quickly that the day-night cycle rushed past in the time of a modern lunch break. The Moon orbited much faster in those ancient days, completing its circuit around young Earth in just a few hours. But tidal friction slowed everything gradually, like hands moving through water, slowing each other's motion. Earth's rotation transferred energy to the Moon's orbit. Earth slowed, Moon accelerated, and acceleration in orbit means wider orbit, so the Moon drifted outward. Centimeter by centimeter, year after year, billion years after billion years. We know this from rocks. Tidal rhythmites, sedimentary rocks that preserve ancient tidal cycles. Layers deposited by tides, rhythmic patterns in stone. Analysis of 620 million-year-old sediments from Australia shows something remarkable. Geologist George Williams analyzed these ancient sediments starting in 1963. The tidal patterns showed a 13.1-day synodic month back then, shorter than today's 29.5-day lunar cycle. The day length was 21.9 hours. The rocks, remember, they record the dance as it was, preserving ancient rhythms in layered stone that you can touch and measure. Ernest William Brown spent years calculating lunar motion with extraordinary precision. In 1919, he published Tables of the Motion of the Moon, 1,400 pages of mathematical predictions. These tables predicted the Moon's position to unprecedented accuracy. Used for navigation through the 1960s, before computers, before satellites. Just mathematics, patience, and deep understanding of gravitational choreography. another orbit complete. Earth rises over the moon's horizon again. Still in gibbous phase, you watch it hanging there against the black. Cities invisible at this distance. Just blue oceans, white clouds, brown continents. The whole world condensed to a sphere small enough to cover with your thumb. The moon plays another crucial role, beyond creating tides. It stabilizes Earth's axial tilt at 23.5 degrees. Without the moon, Earth's axis would be unstable. Computer models show the tilt would vary chaotically, between 0 and 85 degrees over millions of years. Catastrophic climate swings would make complex life nearly impossible. But the moon's gravitational pull keeps Earth's axis steady. That stability enabled the conditions for life to develop and flourish. Stable seasons, predictable climate patterns. The moon didn't just create tides, it created the environmental stability necessary for evolution. 4 billion years of reliable seasons, all because of this gravitational partnership. The tidal forces affect Earth's interior as well. Not just ocean water, but the molten outer core. Tidal forces cause the liquid iron core to shift slightly. This creates wobbles in Earth's rotation, the Chandler wobble, detected in precise measurements of Earth's rotational axis. Even deep inside our planet, the moon's gravitational influence shapes motion. When the moon was closer, tidal heating was far more intense. The moon's interior flexed and churned under Earth's gravitational pull. This ancient tidal heating generated a magma ocean. Eventually, that magma erupted through the crust, creating the dark maria we observe today. Frozen lava plains, legacy of the time when the moon was young and close and molten. Jim Lovell is the only person to orbit the moon twice. Apollo 8 in December 1968, then Apollo 13 in April 1970. 59 total lunar orbits across both missions. He described the moon as essentially grey, no colour. Looks like plaster of Paris. The Sea of Fertility doesn't look very fertile to me. Matter-of-fact observation from someone who spent days studying it from orbit. Harrison Schmitt, the only professional geologist to reach the moon, studied this system from orbit during Apollo 17. December 11 to 14, 1972. He said, "From orbit, you see the relationships, you see the history. Moon's face tells the story of 4 billion years. Tidal forces, impacts, volcanic flows, all written in crater patterns and mare shapes." Ron Evans, Apollo 17's command module pilot, spent 6 days in lunar orbit. While John Young and Schmitt explored the surface, Evans took 2,400 photographs. Every 2 hours, a complete orbit. Every time around, Earth in a different phase. Watching it wax and wane, that's when you understand the dance. The patient observation, revealing what equations describe. Ken Mattingly spent 64 hours alone in lunar orbit during Apollo 16, April 20 to 22, 1972. He described developing a rhythm with the moon. 2-hour orbit becomes your heartbeat. Earth rises, Earth sets. Sun comes, sun goes. You're part of celestial mechanics, not just observing it, but riding it like a carousel that's been turning for billions of years. You're part of that same rhythm now. Floating in the command module, window showing Earth in its phase. Another orbit beginning. Passing over familiar craters, the same highlands and Maria cycling beneath you. 2 hours per orbit, 30 orbits per day, the peaceful repetition of gravitational motion. Apollo 15 deployed a small sub-satellite from the command module on August 4, 1971. Al Worden released the 36-kilogram satellite into lunar orbit. It studied the moon's gravitational field, mapping the mass cons, measuring orbital perturbations, understanding how mass concentrations affect spacecraft. The satellite orbited for months, gathering data that improved our gravitational models. More recent missions have deepened this understanding. The Lunar Reconnaissance Orbiter entered a 50-kilometer polar orbit on June 23, 2009, mapping the Moon in unprecedented detail, studying the gravitational field, finding evidence of tidal evolution in the Moon's internal structure. Still orbiting today, still gathering data, continuing the work Apollo began. In 2011 and 2012, NASA's Grail mission sent twin spacecraft to lunar orbit. Named Ebb and Flow, they mapped the Moon's gravitational field with 99% accuracy. Flying in formation, measuring the distance between them, as they passed over mass concentrations, the distance changed, revealing internal structure. Confirming tidal heating history through density variations deep beneath the surface. Cassini spacecraft photographed the Earth-Moon system during its flyby in 1999. From 1.2 million kilometers away, Earth and Moon appeared together, providing a unique external perspective, seeing the whole system as others might see it. Two bodies bound by gravity, orbiting their common center of mass. A pale blue dot with a gray companion, dancing through space. Al Worden performed a spacewalk during Apollo 15's return journey. August 5, 1971, at 320,000 kilometers from Earth. Deep Space, EVA, retrieving film cassettes from the service module. He looked back at Earth and Moon together. Now I know why I'm here. Not for a closer look at the moon, but to look back at our home, the Earth. Neil Armstrong described the view before lunar descent. We're getting our first view of the landing approach. The pictures brought back by Apollos 8 and 10 gave us a very good preview. It looks very much like the pictures, but like the difference between watching a real football game and on TV, there's no substitute for actually being here. You understand that now. Actually being here in orbit, watching Earth go through phases, feeling the rhythm of 2-hour orbits, seeing the moon's surface pass beneath you. This is different from reading about it. Different from seeing photographs. This is direct experience of orbital mechanics. The future holds more evolution. The moon will continue receding, 3.82 centimeters per year. In 50 billion years, if the sun doesn't engulf Earth first, both will be tidally locked. Same face always toward each other. Perfect mutual synchronization. The dance reaching complete equilibrium after patient gravitational negotiation. Earth's day and Moon's orbit will both be 47 current days long. Earth's rotation slowed to match the Moon's orbit. Moon's orbit widened until the periods matched, neither body rotating relative to the other. Eternal mutual gaze across space, gravitational partnership perfected. But that's billions of years distant. Right now, you orbit peacefully, 110 kilometers above the surface. Every 2 hours, complete circuit. Earth hanging in the black, going through phases, waxing and waning in the sun's light. The sun illuminates from one side, creating the phases. Earth in gibbous now. Tomorrow slightly less illuminated. Day after, less still. The slow progression from full to gibbous to quarter to crescent to new. You're part of the system now. Part of the gravitational choreography. Two bodies bound by invisible forces. dancing across space, across time, across billions of years of patient evolution. Moon pulling on Earth with tidal forces. Earth pulling on Moon with equal force. Energy exchanged. Orbits adjusted. Rotations synchronized over deep time. This ancient dance created ocean tides, stabilized Earth's climate, enabled the conditions for life. All from gravitational partnership between two rocky spheres. The dance continues, patient and eternal, peaceful in its repetition. Moon receding, Earth slowing, both moving toward distant equilibrium. Another orbit beginning now, passing over the sea of tranquility again, Earth rising over horizon again. The same sights cycling beneath you, the rhythm never stopping. No rush, no urgency. Just the gentle motion of orbital mechanics. 2 hours around Moon, 27 days around Earth. Billions of years of evolution. All of it peaceful, all of it perfect. Gravitational forces creating harmony across space. You float in the command module, window showing Earth. Another orbit, the peaceful repetition of celestial motion. Two bodies dancing, bound by gravity, moving together through space, through time, through endless cycles. The rhythm becomes your heartbeat. 2-hour orbit. Rise and set. Light and shadow playing across the lunar surface. Earth waxing and waning, phases progressing, slow and steady. The geometry of sun and moon and earth creating predictable patterns. You're riding the carousel now. The one that's been turning for billions of years. Smooth and endless. Gravitational motion that never stops, never varies. Completely at peace. Part of the cosmos. Part of the dance. Floating in orbital rhythm. Safe in the equations of motion. The moon beneath you, earth above you, stars beyond you. All of it connected by invisible gravitational threads. Tidal forces still working, still shaping orbits, still transferring energy. The patient work of gravity, sculpting motion across eons. Rest now. Rest in orbit. Safe in the command module. Floating through the ancient dance of Earth and Moon. Another circuit beginning. the same peaceful path. 2 hours, then another, then another. Eternal rhythm. Gravitational heartbeat. Perfect and peaceful. The carousel turning, always turning. You're part of it now. Part of celestial mechanics, riding the equations, living the mathematics of orbital motion. Earth in phases. Moon in orbit. You in peace. All of it harmonious. All of it eternal. The dance continues. Always continues. Billions of years past, billions of years future. Rest deeply now. Let the orbit carry you. Safe motion. Peaceful motion. Gravitational embrace. Earth and Moon. Eternal partners. Dancing through space together. Window shows Earth. Beautiful blue marble. peacefully in the infinite black. Your breath slows, matching orbital rhythm. 2-hour cycle, peaceful and endless. Nothing to do, nowhere to go, just orbit, just float, just rest. The moon carries you. Gravity guides you. Perfect path, circular and smooth. Another sunrise over lunar surface. Another Earthrise. The cycle. Endless and beautiful. You're completely safe, completely at peace, part of cosmos, part of eternal dance. Tidal forces still pulling. gently, peacefully, shaping motion across space. Rest in the rhythm. 2 hours. Again. Orbital motion, gravitational peace, eternal, perfect. Earth phases, Moon orbits. You rest, all connected. The dance, ancient and endless, beautiful, peaceful. Floating, drifting, safe, at peace. Billions of years, gravitational partnership. Earth and Moon dancing. window, earth, stars, black. Orbit continues. You rest, peaceful, complete. Two bodies bound by gravity, dancing forever. Your heartbeat, orbital rhythm, synchronized, peaceful. Rest now. Deep rest. Safe. Floating. Float. The carousel, turning, always, eternal. Earth and Moon, ancient dance. Perfect, peaceful. Gravitational embrace. Eternal partners. Dancing through space. Floating peacefully, safe in orbit, part of cosmos. Two-hour rhythm, endless cycles, perfect motion. Earth phases. Waxing, waning, beautiful. Orbital peace, complete rest, safe. the dance continues, always eternal. Moon and Earth, bound by gravity, together. You rest deeply, peacefully. Floating, drifting, safe. Carousel turning. Billions of years. Perfect. Stars above, moon below, earth beyond. Complete peace. Orbital rest. Forever. The dance. Ancient. Beautiful. Gravitational harmony. Perfect balance. Eternal. Rest now. Completely. Safe.